Hello everybody, today I am back with another video, and today I'm going to be covering a topic that is in Calculus BC, and it is in the Unit 10 of Infinite Series and Sequences, and it is the Divergence Test, and yeah, so let's just jump right into it. So, say we have a series right here, where a of n, where we have a of n at n equals 1, and it goes to infinity. So let's say we have this, and we want to find out whether it diverges or not. So, for the divergence test, what it says is that if the limit as n approaches infinity of a of n, notice it's not the series, just a of n, so just this part right here. If it does not equal 0, and I did not write it, then the series, this doesn't apply to sequences, series diverges. You can say with 100% accuracy if a of n does not equal, if the limit as n approaches infinity of a of n does not equal 0, then the series diverges. And you can say this with 100% confidence. So let's say we had a series such as, let's say here, n equals 1, it approaches infinity, and let's say instead of a of n, let's put n plus 1 over 2n plus 1. And this problem right here, let's solve for the limit of it. We want to see if this diverges or not. Some of you already may know the answer. And so let's go with this. And, alright, just make sure. I just don't want to miss anything. 2n plus 1. So, we're going to find the limit of this, and some of you can calculate it pretty quickly. It's going to be 1/2, and that means it is not equal to 0. That means that this series will diverge. So, n plus 1 over 2n plus 1, as the series goes to infinity, it will diverge according to the divergence test. That's how you'd write it. However, what if we had a situation such as this? Instead of the previous one, let's say we have 1 over n squared. And that's n, by the way. Let me just make that a bit more clear. It kind of looks like an h. 1 over n squared. So, we can calculate the limit as n approaches infinity of 1 over n squared. And then this will equal 0. Remember, if the limit as n approaches infinity of a of n is not equal to 0, then it will diverge. This equals 0. We did the divergence test. We found that it equals 0. But does this mean it converges? Converging, if a series converges, that means it doesn't diverge. Well, we can't really say that it converges, but we can say that the series is inconclusive. Sorry, not the series. The test is inconclusive because it didn't prove anything. This means that we would normally resort to another test, and there are more tests that you'll learn throughout this unit, throughout Calculus BC. There's the integral test, the alternating series test. You don't need to understand what they are right now, but I'll probably make videos on them soon enough. But yeah, those are some examples of other tests that you could use. They require a few more steps here and there. But this one is by far, I think it's the most simple out of all of the tests, if I remember correctly. Yeah, but it's a pretty good one to just check off if it's divergent or not. And I'd recommend starting with this test. One thing to note, the reason you can't prove that this here isn't divergent. So this, you can say when it equals 0, you can't say it's convergent. And let me give you an example of one series that would be divergent even though the divergence test does not work. So here, let me just move over here. And that would be, and some of you may know the example. You may have seen it if you've read ahead in your calculus textbook, or you just know it from someplace else, it would be 1 over n. Notice I put 1 over n squared here. 1 over n. Now what's so special about this series? Well, you may have heard of a term called the harmonic series, and the harmonic series is actually always divergent, and this is actually proven by the integral test. If you perform the integral test on it, then you'll actually find out that it's divergent. But you'll notice that when we take the limit as n approaches infinity of 1 over n, we actually still get 0. This means that the divergence test doesn't work, and if you guys know about the harmonic series is always divergent. The divergence test didn't work on it, so this means that you can't always say that if the divergence test fails, say the limit of n, a limit as n approaches infinity of a of n, if that does equal 0, if it does equal 0, then you cannot conclude that it is convergent. You can conclude it is divergent if it does not equal 0, but not the other way around. Anyways, guys, that is going to be it for this video. Keep in mind that last part. That part is kind of important when dealing with the divergence test. I hope you guys did find this video helpful about the divergence test. This is a topic that shows up in series and sequences, as I mentioned earlier. Calculus BC, or if you're taking a Calculus 3 or a Calculus C course, the third quarter calculus course would be a better term for it. If you're taking any of those courses, you'll find this test quite helpful. It's a pretty easy test to grasp in terms of in terms of simplicity. So yeah, I hope this video wasn't too complicated. I hope I didn't overcomplicate things. And anyways, thank you guys so much for watching, and be sure to leave a like if you did enjoy it. Be sure to hit the subscribe button if you would like to see more of this. And yeah, that is going to be it.